All right, thanks, Gwen. Just switching gear here for the largest telescope planned in the next decade, the ELT 39-meter telescope, which you see here in picture. You should go to check out the website that has been recently restructured and revamped with very nice animations and pictures of what it would look like. You can see here some of the NASM's platform here you have on the sides of the telescope when we can put instruments, and the size of the dome to contain this 30-meter telescope. It will have adaptive optics with a laser system, which I'll get to you later. So you see here what it might be looking at. The timeline for the ELT is actually to have a first light in end of 25 or early 26. That was, to be honest, pre-COVID, with three first light instruments: an imager, Mikado, IFU, Harmoni, and then another far infrared instrument, which I won't talk about. For Harmoni, I will start with Harmoni. We are in a final design review that's starting this year in 2021 and will end in 2022. And then the first light will be matching the telescope schedule. HIRES is a little bit of a different schedule, hasn't really completely started, and should be coming on the telescope but 5 years later. HIRES in high resolution spectrograph with a resolution of about 100,000. For Harmoni here, the key numbers, it's a slicer-based IFU with 8 slicers for the 8 subfields with 8 near-infrared detectors and 4 optical, so we would cover the full optical near-infrared band from 0.4 micron to 2.5, with 4 different spatial scales, with pixels or spaxels from 4 milliarcsegons to 30 by 60, giving a field of view that ranges from 6 arcsegons by 9 arcsegons to something that would be about 10 times smaller for the smallest spaxel scale. This would be the largest IFU 30-meter class telescope. Near-MOS would be larger, but marginal. We'll have different modes and resolving powers. They will not be simultaneous, so we will not be able to cover the full infrared band at the same time, but at least you can choose different resolution for each of these bands. And also 4 operation modes for no AO with lasers, the tomographic AO, the single conjugate AO, operational AO, and the high contrast AO if you want to do exoplanet kind of coronagraph in there.
I don't want to interrupt, but there's a lot of static on your line, so if you could talk a little bit louder, I think it would be easier to hear. Apologies.
Yeah, I'm not sure where it's coming from.
I think it's Bluetooth audio, honestly. I have this problem sometimes too.
So here the key science case. You can see here the antenna galaxy that has been simulated at different spaxels and spatial resolution for the Harmoni configurations. And here I'm listing 3 key papers that have looked at the kinematics for Mach observations from simulations of galaxies, or the CGM with Mach H alpha observations. And here is a recent paper by Kern Grisdale showing Mach observations of faint population 3 stars and tracing the helium-2 line. And there's also here at the bottom a link here of the Harmoni simulator. So if you have a cube from simulations, and that is a cube, a FITS file with the units in flux that are going to be compatible with the Harmoni simulator, you can just plug it in and see whether your line or your data will be visible at the resolution or the grating that you want to do. I will skip that. This was just a slide to say that Harmoni will be the largest IFU for this large telescope. Yeah. So moving on to HIRES. Here the specification for HIRES is a high resolution instrument, spectrograph, a single object spectrograph, long slit with a resolution of 100,000. A coverage or in wavelength similar to Harmoni from 0.4 to 2.5 micron, and here also with incredible stability in the wavelength calibration from at least 1 meter per second, and the goal is to go to 2 centimeters per second. And the reason for that is people want to see the shifts with time of the lamina forest to do cosmology, and that's the so-called sandwich test. It might have a small IFU of 4 arcsecond, a single IFU, so no multiplexing, and we'll be doing seeing limited observations or AO. And I'm part of the working group for the galaxies and the CGM or IGM. And one thing that HIRES would be able to do is to do high-resolution spectroscopy of a large number of more quasars. I mean, this picture from Chuck Steidel a long time ago. We want to do the tomography of the CGM for studying feedback. Currently, the density of quasars where you can take a high-resolution spectra is very low. With HIRES and a 39-meter telescope, you'll be able to increase that to about 10 quasar per square degrees, to this kind of limit of 21. So that's one science case. Of course, the other science case that we are interested in the CGM is like after you have quasar spectra, is to find out where the galaxies are associated with these absorption lines, whether for the metal lines or for the forest. So we really need an IFU here to find the galaxies. And this is where I think both BLIMUs will be also revisionary here in this game, because for each of these Lambda alpha forest, H1 absorber will be able to map the Lambda 5 meters and corresponding study with Harmoni, the nebular lines or oxygen lines or H alpha in the near infrared. So I think this will be very great combination of IFUs and high-resolution spectrograph to do CGM studies. And that's all I had to say.
Perfect. Thank you. Any questions?